to see you again. We're continuing forward. We're on our new chapter, chapter 7, and we're looking at ratios and proportions. Today's notes brought to you by copier error. So we're going to be writing all of our notes today. Don't worry, I promise to make them as short as possible. So the very first thing we need to do today is define the word ratio. A ratio is simply a comparison of two different quantities. But these quantities are getting compared using division. They look something like this. I have some number A, and then I put a little bar that means divided by. And then I put the other number, which I'll call B. So this gets read A divided by B. That looks familiar, doesn't it? What is it? This right here. What is this thing?
Wait, do it?
This right here. That right there. What is that?
The line, do it.
It's division, which we also see as a fraction.
Fraction.
Yeah, it's a fraction. Ratios are fractions. You've worked with fractions before. I'm going to get you better at dealing with fractions. They're also called ratios. We can write them another way, though. We can write them this way. And this gets read A to B. And this is a comparison. Now, there's one thing that you have to keep in mind. It's like super important when you're dealing with fractions, divisions, and ratios. B can't be 0. The moment we make B 0, this thing becomes some number divided by 0. Can't divide by 0. It breaks algebra. Don't break algebra's heart. Valentine's is soon. Poor algebra. Don't divide by 0. Okay? Let's do a quick example.
Is that a B or
Here? Here? B. Yeah. Here, I'll color code them to make them easier to see. Yes? I know how you feel. All right, here's our example. Our example says, in 2007, a baseball team known as the Boston Red Sox. They won the World Series in 07? Oh, you were just guessing what I was going to write. Well, I don't know if they won the World Series, but they did win some games. They won 96 out of the 162 games that they played that season.
They play 160 games a season?
Baseball's crazy with the number of games. Our goal is to write the ratio of their wins. We need to write it this way as a fraction or this way as a comparison. So to do that, we got to figure out which number is A and which number is B. It says out of, and that's our guide. When it says out of, the first number is the A, the second number is the B. So we can write it as the fraction 96 divided by 162, or as the comparison 96 to 162. And both of those are legitimate ways to write this answer. Yeah? Okay. Now that we're feeling comfortable with ratios, let's add in something called the extended ratio. And all it is a comparison of more than two quantities. So an extended ratio compares more than two quantities. And it looks something like this. Not too scary, right? Here's how we use this. We have a little bit of a word problem. The ratio of the measures of the angles in triangle JKH is 2 to 3 to 4. The directions are find the measures of the angles. First things first, I'm going to draw this thing, just so I can get an idea of where things are, and I have a space to put stuff. All right, so I need a triangle. It didn't tell me what kind, so YOLO. I'm going to draw my favorite kind of triangle. One corner is J, one is K, one is H. It doesn't tell me anything else, so I'm just going to draw them like that and be like, that's good enough. Now, it says the measures of the angles. What do I know about the measures of the angles in a triangle? They add up to 180. Yeah, you could say it that way. So that means that the measure of angle J plus the measure of angle K plus the measure of angle H equals 180. But I don't know the measures of the angles, but I know the ratio that they're in. So if I look at the ratio and I take those as the measures, I have an angle measure 2, an angle measure 3, an angle measure 4. If I add those up, they're not 180. Right? 2 plus 3 plus 4, not 180. But if I were to multiply them all by the same number, by a scale factor, and make them bigger, if I could just figure out what number I need to multiply all of them by to make them big enough that if I add them I get 180, I'm in business. I'll be able to figure out the measure of each of those angles. So the first thing I'm going to do is I'm going to rewrite each one of these so that I have an X on them. Because I don't know what I'm going to have to multiply them all by. So now I have the measure of J plus the measure of K plus the measure of H equals 180. The question you might be asking, how do you know which one of those goes to which angle? Short answer is I don't. The long answer is it doesn't matter. Just put them wherever you want, whether it matches your diagram or not. It'll work out. Okay? Okay. I can add those together. 2x plus 3x plus 4x gives me 9x. And then I want to solve for x by dividing both sides by 9. So if I divide both sides by 9, I get 20. Which is great, but I wasn't after x at the end. I was actually after the measures of the angles. So I want to know, what is the measure of J and the measure of K and the measure of H? Well, I chose J as 2x, K is 3x, and H is 4x. So I should substitute x into each one of these just to see what happens. 2 times 20 is 40. 3 times 20 is 60. 4 times 20 is 80.
Is the middle one a 3 or 2?
It's a 3 and then a 20. This is a 3. I started to write 2 because I don't know why. Because I need coffee. As my daughter says, you need some coffee? I have no idea. And if I were to add those up, 40 plus 60 plus 80, I would get 180, which is what I was hoping for. And so that is my answer. Please note that on the homework practice assignment, you might not be asked for the measures of angles. You might be asked for length of sides and been given some perimeter. The process is the same, except instead of using 180, you're going to use whatever they give you as the perimeter. Okay? But the process is the same. Okay. Who is a little blurry? Focus. Good. All right. On to the last part of our notes, and then we'll look at the homework, okay? We'll check to make sure all the directions make sense before I let you go all on your own. All right. The last concept today is proportion. And a proportion is what you get when two ratios are equal to each other. Okay? It looks a little something like this. Fraction equals fraction. That looks familiar, doesn't it? Yeah. Again, we have the restriction that neither B nor D are allowed to be 0. Again, because we're dividing by them. And if we divide by 0, we break algebra, bad things happen. Let's not do that. A and D in that special relationship are called the extremes. And B and C in this setup are called the means. I haven't figured out why, but they are. So if you hear me, oh, just multiply the extremes. Those are the ones I'm talking about. Okay. I'll just add a bit of color. Now the question comes up, how do I handle proportions? What do I do to solve them? Well, you've handled this a lot before. You guys are actually really good at it. We've done it a couple times in this course already. So I'm going to give you the name of something. We're going to talk about it. And as soon as you recognize what you're used to calling it, just go ahead and shout it out, okay? In order to handle proportion, we're going to use the cross product property. He said, cross multiply? Yes, the cross product property is indeed known as cross multiplication. The word product just means multiply. All right, so the cross product property says this. If I have two fractions and they're equal to each other, ladies, stay with me. Thank you. Then all I have to do is take the extremes, multiply them together, and set them equal to the means multiplied together. I'm going to add a little bit of color here just to make things kind of pop a bit, okay? Okay? Easy enough? Right? Feels comfortable? Let me do at least one example with you with ones that might not be completely familiar or that it's been a while since you handled them. Bless you. Okay? And we'll use that as the example. And then we'll call it a day for notes, and then we'll just look at the homework and make sure you're feeling comfortable. To this? Okay, good, thank you. All right, so the example, stay with me, stay with me. The example I would love to work with you on is this one. X over 8 equals 2 over x. The question is, what's x? All right, I'm going to use cross multiply. I'm going to take the extremes. Whenever I have x times x, I get x squared. And then I'm going to take the means. And you said that 8 times 2 is 16 is what he said. So now I have something to a square power. How do I get rid of a square power?
Square root.
That's what squaring means.
Square root.
Square root, is that what you say? No? Yeah? Yeah? Okay, I'm sorry, I didn't hear you. I heard you say something, but then she caught my attention too. So square root the thing, yes, indeed. And so I have that x equals 4 because as you had said, we want the number that multiplies to itself and gives me 16. That's what square root means. Okay? I want to show you one more. Won't work it out completely, all right? But I want to show you what happens when we have some addition and subtractions in our fraction. Okay, let's say we have fractions that look like that instead. Already looks way more complicated, right? But take the extremes and multiply them. This thing times this thing. I don't need to know what that number is. I just need to know how to multiply them. And you set that equal to whatever you get when you multiply the means. Again, I don't need to know what those numbers are right now. Now that I have this, I can distribute. That times that, this times this. That times that, this times this. Feels familiar now? Good. That's all I had for notes today. Thanks, guys.